This is page 73 in our notes today. My colors are green and black. Continuing on with Geometry 2 volume notes. So we had a couple examples we did yesterday. I believe there was 4 on that little half page we had glued in our notes. This is continuing on with that. A couple things I want to write down. What do we know about volume? Volume is the amount of space inside of an object. Amount of space inside an object. How do we measure volume? It is measured in units cubed, centimeters cubed, inches cubed. We're thinking about filling a shape or an object full of cubes. So we always think about filling it full of cubes. It's also got 3 dimensions. That's why we label it like that. So the formula for volume, most of the time you see the formula length times width times height, and those are all like cursive letters that you see that. So I want to box that in. I want to star it for our formula. Most of the time you see length times width times height. What we did yesterday is we talked about the volume was the area of the base. So if you take length times width and you multiply them, you get the capital B. They're calling that the area of the base. So volume equals the area of the base times the height. So I'm going to label that area of the base and then times the height. That's another way to look at it. How do you get the area of the base? It just depends on what shape your base is. For example, if your base is rectangular, then length times width works. So let me put it over here. Area of a base that is rectangular. I'm going to draw a little rectangle here. Then you just take length times width. If you want to find an area of a base that's triangular, like we did yesterday in some of our examples, area of a triangle base, area of a base that is, triangular in shape, then we use our base times height, and we have to divide it by 2. It's also referred to as 1/2 times the base times the height. A lot of times you won't see the dots in here to multiply them, but that's still what it means. So I want to make sure you understand how to find the area of the base. Could there be different dimensions to get the same area of a base? Yes, and that's actually what we're going to talk about. This formula, you should be able to work it forwards and backwards. So we're going to do some more examples of volume problems here. So we'll just draw a little wavy line here. This example 1, I've got the L, which obviously stands for length, is going to equal 2 centimeters. The W equals 4 centimeters, and the height equals 6 centimeters. And the question is, obviously, what is the volume? So you need to know what to do with these numbers, 2, 4, and 6. Well, when they have a length, width, and height, and they're asking for volume, remember our formula is volume equals length times width times height. I like writing the formulas out, and then I like putting the blanks under volume. You've got your equal sign. You have a blank under L, a blank under W, and a blank under H. Fill in the ones you know to help you solve this. Our length was 2, so that goes under the L. The width was 4, that goes under the W. And the height was 6, so that goes under the H. 2 times 4, length times width, is how we get the area of the base, which would be 8. In this case, these are labeled centimeters, so I could call that centimeters squared. And then if I still take it times the 6 centimeters, which is not squared, these two times each other gives you 48. So a lot of times you just want to write over here 48 centimeters cubed for the volume. Could you go back in and put that up over here, 48 centimeters cubed for your volume? Yes, it doesn't matter if the answer is on the left or the right, just most kids like it on the right. So length times width times height is one way to remember volume. Always labeled cubed. You're filling an object up with cubes. I want to give you one similar to what you're going to see on your test. So I want to put that over here. This is on your test. So I want to make sure that you understand. Put a star here. You need to study this. This is why we're writing in your notes. You'll have something similar to like this question 4 and similar to question 6 on your test. So I want to make sure you really understand this. First off, I'll give you some information over here on the right. I'm going to tell you that the volume is 240 centimeters cubed, because that's our volume, cubed. The height is going to be 10 centimeters. And so the question is, what could be your dimensions of the base? So when I think about volume, this would be like a rectangular prism. So let's go to the formula. Let's write what we know about the formula, that volume equals length times width times height. And then you fill in what you know. Do you know your volume? We have the equal sign. Do we know the length? Do we know the width? Do we know the height? So we fill in what we know. We actually know our volume is 240. So we can fill that in here. We know our height is 10. So we still don't know the length or width, so we can still fill those in with variables. So we know something times 10 is going to give us 240. So another way to kind of narrow this down is when we were talking about solving the equations, is do the opposite. Instead of timesing by 10, let's divide by 10 here. This will cancel this out. Whatever you do to one side, you have to do to the other side. So 240, if you divide by 10 over here, 240 divided by 10 gives us 24. 24 still has to equal our length times our width here. So what I'm asking is how could we get 24? What could be our length and our width? Is there more than one dimension that length and width could be to equal 24? Yeah, there's actually several that would equal 24. So I'm going to give you a couple examples, and I think you could probably solve some. So your length and width, probably the most common ones people think about is 4 times 6. I could see a 2 times 12 giving you an area of your base of 24, because length times width gives you the area of the base. 4 times 6 would give you kind of a rectangle shape. 2 times 12, you could have 24 times 1. That'd be kind of a skinnier base, and then you could even have 3 times 8. Those are all examples of what your length and width could be to give you a 24 for your area of your base. If I ask you to draw those, what does that look like? What does a 4 by 6 look like? Well, if you kind of think about like 4 going down, 6 would be it's kind of like a rectangle more like this, like 4 by 6. So then that would give you the area of 24, kind of rectangular shape. 2 by 12, so it's not quite as big as 4, but then 12 would be double the size of that one, so something like this. 2 going down by 12 going up, which still gives you an area of 24 for the base. If you were looking at a 24 by 1 or 1 by 24 even, 1 is pretty skinny, and then 24 is bigger than 12, so it would be more like this. So the base would be very kind of longer, skinnier for a base, still giving you an area of 24. And I have models of these bases to show you. A 3 by 8 would be like going down 3 and over 8. And so it would look more like that. 3 by 8, which would still give you an area of 24. So all of these bases would be 24, and then all of their heights would be 10. So they'd be the same height going up, but the area of their bases are still 24. They just look different. Some of them are all longer, skinnier rectangle than these ones are.